Hello everyone, my name is Andrew. Today we continue learning Python, and today we will create an event sourcing application in Python. So let's start. In one of my previous videos I talked about event sourcing, what that is, how does it work, and if you have no idea what I'm talking about right now, then you can watch that video. So it's gonna pop up somewhere here, and let's just create our application. So we're gonna start with the most simple thing, which is events. I want to remind you that in event sourcing we store everything as events. So whenever something happens, that's an event. For example, your user was created, your user balance was changed, and in normal applications that do not use event sourcing, we may store everything as just state changes. So balance is that, or balance is that. So for example, your user balance was 100, but then you said that, I received another $100, so my balance is 200. So you just change the balance of your user as the current state. However, in event sourcing applications, we don't do that. Our balance was 100, then we add to our balance 100, then we add another 100, then we subtract 10, and so on. So we can store the sequence of events and therefore reproduce the state of our application at any point in time. That's the basic idea, and I created a file called events.py, and I'm gonna store those events in here. So the first thing that I'm gonna create is event class itself. It's gonna be just like a base class for all the other events. We're not gonna use it directly, but I'm gonna use it in annotations, and maybe if you're gonna add a database or somehow use that project as your skeleton for event sourcing applications, then you can use that event in order to do something. So all the events will inherit that event class, and yeah, let's just start. So what I'm going to do here is I'm going to import from data classes, I'm going to import data class. If you have no idea about that thing in Python, then you can watch my other video about data classes. But what I'm going to do here is add data class decorator and create one event called user created, just like that. So our application will have two events. We're going to have user created event that is going to be invoked when we create our user, and we're going to have another event called user balance changed. So let's create that event as well. Data class user balance changed, and let's not forget that we need to use event as our base class here and here. So I created two events, user created and user balance changed. One important thing that I want to tell you right now is that you need to name your events in past tense. User created, balance changed. You cannot name your event create user or user create, because that's not an event, that's a command. And event indicates that something happened, something took place. And because of that, took place, we need to name it in past tense. All the events go in past tense in any programming language, in any framework, in any application. Alright, so past tense. And then what we need to do in our events is add all of the fields that are gonna have the information that we changed in our state, in our database, in our storage. So all of the things that we changed. In our case, our user is gonna have ID, our user is gonna have username as a string, and our user is gonna have balance as an integer. So that balance is not the final balance of a user, that's just like the initial balance of the user. When our client is gonna create his account, he is gonna invoke user created event, and we're gonna assign an ID, we're gonna assign a username and a balance. After that, user balance changed event is gonna take place if our user sends, for example, money to someone or receives some money. So user balance changed event is gonna have ID inside of it and change. Because we do not store balance itself, we do not store like your new balance is 100, your new balance is 20. We store the change of the previous balance, and therefore we can reproduce all the events and get our final state. So that's very simple. In our case, user created is going to pop up when our user is being created, and balance changed when the balance is mutated. So very, very simple. Alright, so we have events.py and we are finished with that file. Let's create another thing called models.py. So models.py is a file where we are going to have our models. So class user. User is a class that will allow us to work with our users and invoke those events. So So what I'm going to do here is create an init function, and my init function is going to accept ID as an integer and none by default. So ID, as I mentioned, is a unique identifier of our user. So it's kind of like just a primary key in a database. We are going to need that ID in order to identify different users, and what I'm going to do here is supply that ID as self.id. But why is it none by default? Because if our user is being created, so user created event is thrown, what we need to do is assign that ID from the database. So you're not going to have your ID inside of like your memory in some sort of a variable. You're going to get those IDs from database sequences most of the time. And because of that, what we're doing here is that when we create our user, we're going to have ID as none. So we don't really need to provide that ID inside of our user. And to be honest, we can just omit that ID at all. So we can just omit that ID and only directly change our variables whenever we hit apply. So I'll show you what I mean, but for now, let's just leave ID as it is. So ID, identifier of our user, and yeah, that's it. Then I'm going to create a username, which is going to be none by default, and balance, which is none as well. We're not going to set up our username and our balance inside of our init function because, as I said, we don't want to just say that user has a balance of something, or that user has username, that username, or another username. We don't want to assign the values directly. We can do that, to be honest. We can do that with projections, and if you want me to talk about that, I'm going to create a separate video where I'll show you how to create projections with maybe materialized views, with your own tables and some sort of that stuff. And I talked about projections or read models in the previous video, so check it out if you want to know what that is. But for our simple application, we do not want to directly assign values to our models, to our user model. And because of that, we are not able to provide username, balance inside of the init function directly. And as I said, to be honest, we can even omit ID. But I'm just, well, let's omit ID. Yeah, I think that it's going to be better if we just omit ID. So every value is going to be none by default. All right. Then what we are going to do is create a new function called Createuser. That function is going to create our user and add a new event. So we need to provide ID as an integer, then username as a string, and then balance as an integer. So we provide all the values that we need in order to create our event, and as I said, ID is going to be retrieved from the database directly or from some other sort of an ID generator. So what you can do is remove it if you want to get it from your database here, but I'm going to leave it to show you how I'm going to do it with my own data storage, with my own state storage. So we're going to have ID, username, and balance as arguments. But what do we need to do right now? Right now, we need to add a new event to our user. We can't just say self ID equals ID. We need to add an event that's going to tell us that your new ID, your new username, your new balance is equal to something. In order to do that, I'm going to create a new array called self events. Just like that. So self events is going to be a list of all the events that we have in our user. So in that specific user, not in all of the users in our application, but in that specific record. And when we are going to have create user, I'm going to create a new function called apply, which is going to have event. We're going to use that annotation here. All right, so we have apply function, and there is no definition for now, but let's just go to create user, and what I'm going to do here is self apply from user created event. Let's import it. User created event, we need to provide ID as ID, username as username, and balance as balance. So what I'm doing here is I'm just saying apply user created event. Just apply it. If you want to run any checks, any validation, you can do it inside of that create user function. Or you can do it in apply, whatever you like. But you can do it in create user function, and let's run that validation in balance changed. Or change balance, sorry, change balance. Because we have not yet created that event. So change balance, and what I'm going to do here is provide an ID And no, actually we don't need to provide an ID here. Why is that? Because if we create our user, we don't have an ID yet. So if we create our user, we don't have that record. But if the balance is being changed, then we should have our ID inside of that user object. So we're going to have something like get the user from the database. That user is going to have ID already, and then change the balance of that user. Very, very simple. So we don't have any ID here, but instead of that, we only have our change, balance change that we have in user balance changed event. I'm going to copy that. And the same goes here, self apply, user balance changed, ID equals self ID. So I get the ID of my user, and change equals change. Very, very simple. And if you want to run any sort of validations, you can do it here. So if self balance, because we already have a balance, we're already changing the user that has an ID. So change balance is executed on some kind of user that already has an ID, balance, username, every field that we're going to need to work with our client. And because of that, what I can say is if self balance minus change, or plus change, because if change is negative, it's still going to be self balance minus change. So if self balance change is smaller than 0, what I'm going to do is erase value error. Balance is negative, because we can't have any negative balances in our users. And that's a very simple validation. So if you want to run some sort of validation, your data formatting, you can do it inside of those functions. But after that, you need to apply your event. You don't need to change any of your fields directly. All right, so we have self-apply here, and user balance changed event is being invoked as well as user created inside of Createuser. What is apply function? Apply function is basically the function that is going to apply all of the events to our model. What I'm going to do here, if is instance is a function that checks if your object is some sort of a class. So if event is type of user created, that means that our event is user created. So the only thing that can invoke that event is Createuser. So that means that if is instance event user created gives us true, that means that we have event as Createuser. So user was created. What I'm going to do in apply is basically say event username. So self username equals event username. Self balance equals event balance. Self ID equals event ID. Because as I said, we don't apply our changes directly. We can't just say that equals something. But here in apply function, we're applying our event. And event is the only thing in event sourcing application that can change the state of our objects, of our records. Because of that, I can say self ID equals event ID, event balance. And let's write another case which is gonna work with user balance changed. And here, instead of just saying user balance equals event change, what I'm gonna do is user balance plus equals event change. Because once again, events, those kinds of events, user balance changed, they represent changes in my state. They do not represent the final state of my record. They represent the changes. And after that, I'm gonna say self events, append my event. Just like that. So that is our apply function. If we have, if our event is user created, we apply the changes for user created, and if event is balance changed, we apply the changes for balance changed event. Very, very simple. To be honest, we add all of the events to our model directly. So if you have 1 million events, that's going to be really, really bad, because you're going to store 1 million events inside of your events array. And to be honest, what you can do in real applications is you can only add the uncommitted changes to your events. So only if the change is uncommitted, like you want to store your events in a list, and if only the change is uncommitted, then you can add those changes inside of the events array, events list. But otherwise, you can use some other techniques or not use events at all. In our case, we're going to use, not use events at all in terms of like a list. Now, in our case, we're going to use events as a list, and we're going to append all of the events to our user. However, in real applications, that's not great, because if you have lots of events, then it's going to be really, really bad for you. I'm going to create a repository file, which is going to have class user repository in here. And the repository is a pattern that allows you to work with your database more easily. If you have no idea about that, I have a separate video for it, so you can watch it and return to that one. Inside of my repository, what I'm gonna do is basically have get method that has ID as an argument and save method that has a user as an argument, just like that. All right, save method and get method, and also I'm gonna have get user ID method. All right, so get method is gonna return our user using its ID. Save method is gonna save our user, and get user ID is just gonna return the ID for our new user right here. Because as I said, we wanna get our user IDs from sequences and all sorts of things that, like IDs, unique keys, we want to get them from sequences. We don't want to store them in our state, because that's how all applications work. It's better to get them from the database that ensures that your ID is unique than getting it from your memory. And because of that, I'm going to have get user ID function. Aside from that, I'm going to have events dictionary. And if I want to use an annotation, I'm going to have that type of annotation, typing dict from integer and event as a value. Not just an event, but rather list of events. So what we have here is we have our events as a dictionary of integers and list of events. And let's define the save function, and you understand what that means. Self events from user.id equals to user.events, and that's it. So that's just it. When we save our user, let me just quickly say if user.id is none, raise value error, user has no data, no ID. Because if our user ID is none, then we may run into some problems. So what we're saying here is that we are getting our events dictionary, and we're saying that user ID, the key for the dictionary, is all of the events that happen to the user, because we don't want to save the user. We want to save all of the events that happened to that record. Because of that, I'm saying that self events from user ID, unique identifier equals to user.events. Very, very simple. If we want to define get user ID function, we can just return len of self events. Why is that? Because self events, let me just name it saved users, because I think it's going to be easier for you to understand. Events or saved users or data, any name that you want, is basically all of the users and their corresponding events. So ID of the user and events that correspond to that ID. And what we are saying in get user ID is we are getting the len of saved user. So we have one user, our ID, our new ID is going to be 1. If we have 2 users, our new ID is going to be 2, then 3, then 4. So once again, if we have one user, so we are starting with an empty dictionary. So len from our saved users is 0. Then we save one user, our ID is going to be 1. Then we save the second user, our ID is going to be 2, and so on and so on and so on. So len from saved users is just like an ID that goes with the length of our saved users. All right, but what is get function? What's the definition of get function? What are we supposed to do here? Basically, what are we supposed to do here is we are supposed to create our user and then get the events for that user. Self saved users.get from ID, because we are saving all of the events using the ID of the user, and we supply our ID inside of the get function. I'm saying get all the events for that ID, so it's going to be events. Let's check if events is none, then raise value error not found, because if we don't have any events that correspond to that ID, then that means that our user is not saved, so ID was not found, no events to apply. But if our events were found, what we're doing here is for event in events, we're saying user.apply event, and then return our user. Very, very simple. For each event in our user events, we applied, therefore we change the state of our current object, therefore we get the final user, get the final state for that record. Very, very simple. I think, yeah, the code explains itself. Let's just create our main.py file, and inside of that main.py file, I'm gonna have a function called main, And that function, it's not a part of the program itself, it's just for us to test the user repository, the user models, and our event sourcing application. So what I'm going to do here is create user repository. Once again, user repository is the class that allows us to work with our imaginary database. If you want to connect a real database, then basically what you need to do is just change it to SQL queries. But I'm going to talk about that a little bit later, because there are tons of potential problems with database in event sourcing applications. So there are lots of problems in databases with event sourcing applications, because it's kind of like more complex architecture than just a simple state changes, which are reflected in our data storage. All right, but for now, we just create our user repository and let's create our user model. So user equals to what? To user, to user. And what I'm gonna say here, that's important, what I'm gonna say here is user.create_user. So we need to, first of all, create the user, the client that we want to work with. I'm gonna say user ID equals to user repository dot get user ID, in order to get our new ID, in order to get our unique identifier. I'm gonna say ID equals to user ID, then username equals to something like Andrew, and balance is 0. We're gonna start with no balance at all. All right, so we created our user. What are we supposed to do after that? After that, we are supposed to fix a bug. Yeah, I remember that we have a bug here in user events. All right, it's all right. Let's just I'll show you what that bug is, but we need to create our user after. We need to change the balance of our user after that. So user to change balance. Let's change the balance by 10. Then add 1, 2, 3, so 123. Then let's subtract 50, and that's how we're gonna change our balance. So as you can see, I changed the balance of our user 3 times, and if I'm gonna print my user, just like that, models.user, let's print our user.username, user.balance, and user.events in order to see all the things. So as you can see, username is Andrew, balance is 83, and here are all the events. We created our user, we changed our balance by 10, we changed our balance by 1 to 3, we changed our balance by minus $50, bitcoins, or whatever you want to imagine as the balance for our application. And that's how we can store our events. However, there is a big bug inside of our repository. I explained how Python memory works in the previous video, so you need to watch it in order to fully understand what I mean. But in user events, like in that user.events, we are using a link directly to that events list. And because of that, both of our saved users and user objects are gonna be referenced in the same event object inside of the memory. So the only thing that we need to do is just copy it as a list. If you don't understand what I mean or don't know what I mean, then just don't worry, copy it as a list, and that's it. So you need to copy it as a list in order to create a copy of your user events. Because if I want to delete my user.events, my database will still have our events saved. That's kind of it. Let's check our user second. Let's check our repository, user repository get function. So get by ID, which is user ID that we created here. And what I'm going to say is user to username, user to balance, and user to events. Let's run it. Not found. Really interesting. User was not found. How come? Oh yeah, because I did not save my user. So yeah, I need to call user repository dot save from the user. Now we save all the events for that particular user and we receive them afterwards. So as you can see, our application is relatively simple, but now we can see all of the events that took place on that user. User created, user balance changed, and so on and so forth. But what I want to say is that with event sourcing, then there may be a lot of problems. So first of all, we don't create a real database, and with real databases like SQL databases or any other event storages, what you can have is a lot of problems with how to store your events, how to store your projections. So if you don't know about read models or projections, Yeah, I call them read models, but they're called projections in real world, then you should watch my other video or wait for another video to occur on that topic. So there are tons of problems. You need to consider how we apply those events. Because if we apply 1 million events in our user, then it's not going to be a really, really great thing for our scalability, for our performance, because yeah, we have tons of events. You need to think about the IDs of the user. So how to get an ID of the user, how to insert events in our database, because each event should have an ID and each event should be in some sort of order. Because if we, for example, let's look at our events. Imagine that instead of user created, the first event was user balance changed. What? User balance changed, then our user was created. That's kind of strange. So how did that happen? Because of that, you need to somehow order all of your events, and you have a lot of problems with concurrency, you have a lot of problems with other things. However, now if you use event sourcing, you can see the whole state of your application and you can reproduce any point or any state of your application in the past. And that's a very, very great thing to have. Of course, you should not use event sourcing in all of your applications because you have other ways of reproducing your state, but that's a very specific architecture that you may want to use. So thank you for watching. My name is Andrew. Subscribe to my channel, leave a like, leave a comment. Code that I wrote today is in GitHub using the link below, so you can find it there. Thank you for watching, and bye-bye.